No sound. No sound. No sound. No sound. No sound. Oh, let me check. Okay, now tell me if the sound is there. First tell me before I start telling me in the comment section that the sound is there. Tell me, tell me, tell me. I'm waiting for the comment before I continue. Ne? Yeah. The sound is there. Ne? Is the sound there, guys? Yeah, I think the sound is there, ne? All right. If the sound is there, let's continue. Hey, I was saying, now it means that I have to repeat whatever I've said before because I thought that I'm on the point. All right, I was saying that the paper looked to be simple, but it is a bit difficult, most especially for those people who did not participate in terms of preparing very well. However, these examiners this time for physical science, I don't know whether it's a new person. I saw one of the comments that this minister must be fired. Who is gonna fire him? Fire! Hey, please don't talk about our minister. Yes, that is the level of education we need. Ne? However, we don't want our babies, you babies, to fail. That's the very big challenge. So anyway, let's find out. I know that you guys did not let me down. Let's continue. He said that which one of the following compound has hydrogen bonds? We said that is an alcohol. We said is C. Then we said that 1.2. We said that which one of the following is a correct general formula for carboxylic acids? I said it like that. And then I said it is you have to write the maybe a carboxylic acid. After writing a carboxylic acid, you find out how many carbons. 1, 2, 3. So 3 carbon atoms, meaning that CN is 3, ne? And then hydrogen is 3, 3 plus 2 plus 1, which makes them 6. That's why I'm saying that 2N, which N is the 2 times the N, which is 3 times 2 times 3, which is 6. And then the oxygen, there are 2. That's why I wrote it there. And then I said C. We continue. Yeah. This year, examiners. Yes. Yeah, guys. This year, examiners for physical science. We need to do a research about it. Ne? All right. Let's continue. Saying that the study reaction below. Reaction 1. Okay, you have the reaction this, which gives me this to form this. Ne? Guys, if you have a challenge, let me know before I go to another question. Don't say after me leaving and then say that, sir, I didn't understand this. Your answer is wrong. Let me know before I go offline. Yes, sometimes when you are doing the calculations, yeah, you understand. Yes. All right, let's continue. I'm saying that, yes, you have sulfuric acid here, and then you have a compound P, a major product. The moment you have sulfuric acid and this is an alcohol, it means that that is what we do is the dehydration. So it means that the major product which you're going to form here is an alkene. But an alkene is going to have this bond where? It's going to have a bond where? Ne? It's going to have a bond there, and then now it's going to be an alkene. Yes, it's going to be an alkene. Yes, so let me write it here, and then you see what I'm saying. CH3, CH2, CH, and then yeah. Okay, so it's gonna form an alcohol there, and then it's gonna form that there. Yes. So it means that what's gonna happen here, the major product, the minor product, an alkene is gonna form here, while the major product and alkene is going to form here, meaning that this and this, so that you form a symmetrical, meaning that a minor product, a major product is going to be, first of all, is going to be 1, 2, or 1, 2, meaning that it's going to be 2 butene, but 2 in, 2 but 2 in, so I have this and I have that. Yes, but now after that, reaction 2, the same compound here. Yes, I'm having this plus hydrogenation, meaning that now I convert it into an alkane. You understand? Hydrogenation. So it means that it's gonna be so this is not alkane, so that one goes out, while this is gonna be an alkane. Therefore the answer becomes B. Yes. Who got B? Yeah, who got B? Who got B? Then the next question, they are saying that 1.4. Yes, if you look at 1.4, yes, they're saying the potential energy diagram below is okay. shown as x plus y gives you z. Yeah, so x plus y gives you z. So what is happening here? So look, the forward reaction, it means that if you look at that, that is the activation energy. Yes, and then this is the what? If this is A and then this is B, this is the enthalpy change. But for the reverse reaction, look, for the reverse reaction, yes, for the reverse reaction, I'm going to call it C. C must be equal to A, yes, A plus B. You understand? So I come here, I look at this. What is C whereby C is equal to A plus B? First of all, for the forward reaction, the activation, the enthalpy change must be negative. So it is either this, or this. So this one is out. This one is out. So what is C equal to A plus B? So C is equal to, if it's this, meaning that this is A, this is B, must be equal to C. So here is out. Yes, this is out also. So the answer is yes, is this, meaning that you ignore that, because that shows the whether is endothermic or exothermic. All right, so the answer here becomes D. So D becomes the most correct answer. 1.5, initially equal number of moles of hydrogen gas and iron gas, iodide are mixed in a closed container. The reaction reaches equilibrium at a constant temperature according to the balanced equation. All right. They're saying, sir, when do you do KC? Show, yeah, I'm going to do that. I need to go through everything and so that we reach there. Then they're saying that this plus this gives you this, all right. Because it's 1 mole, 2 moles. So meaning that hydrogen must be equal to, hydrogen gas must be equal to iodide. Yes, and then it must be equal to 2 moles of that. You understand? Yes. So meaning that hydrogen is equal to this. The concentration of this must be equal to the concentration. Cool. Yes. But basically the number of moles, this and this. No, it can't be, because this one 2. So this is out. This can't be this. Yes. This is 2. This is 1. So if this 2, this one are supposed to be no. So the answer, this one is equal to this. No, it can't be that. The most correct answer here is this A, whereby hydrogen have the same number of moles in that regard. Yes. So here you get 2 marks there. Then we go to question 1.6. Consider the following reaction equation. Sulfur dioxide plus this gives you that. All right. Then they are saying that which one of the following changes condition will increase the yield of that will increase the yield. Addition of this, yes, this one increases because you have added more, so meaning that the further reaction is going to be favored so that it removes that stress. Okay, they're saying addition of a catalyst, catalyst just speeds up, and then increase in the temperature because this is an exothermic reaction, so increase in the temperature can help. Increase in the volume of the container, increase the volume, meaning that you reduce the pressure. And if you look at here, you have 2 and then you have 1, meaning that you have 3 here, and then this side you have 2, meaning that if you increase the volume, meaning that you're favoring the reverse reaction. So basically A becomes the most correct answer and you get your 2 marks. Yes, 1.7. The table below shows the constant Kc for 2 acid at 25 degrees Celsius. Consider the following statement for these 2 acids when they have equal concentration. Both have weak acids. What does it mean? They're saying that butanoic acid is stronger than this. Okay, they're saying that butanoic acid solution has a lower concentration. So in that regard, what are we looking at? Both are weak because the case Ka value is less than 1. You see, it is 0 point something something. So that is correct. The butanoic acid is stronger than ethanoic acid. If you look at the butanoic acid, it has a lower case Ka value than this. So it means that this is wrong. And then this butanoic acid has a lower concentration of hydronium ions, yeah, than the ethanoic acid. Yes, that is also correct. So this is correct, and also this is correct. So I have to look for 1 and 3, which is B. So B becomes the most correct answer. No, so what is that now? Yes, guys, ne? Yeah. Let's go together. I'm saying now, ne? You are making me stronger and stronger and stronger. All right. 1.8. 1.8. You're saying which one of the following pairs of acids and the base all have the same concentration of react to give the highest pH at equivalent point, the highest pH at, meaning that it becomes more basic. So in this case, you have to react with a weak acid with a strong base, so that now you get something which is above 7. So this is a strong acid, weak base. That is out is less than 7. This is a strong acid is 7. This is a strong acid, strong base. Yes, 7. And then this is a weak acid, a strong base. So D becomes the most correct answer. Yes, guys, you are making me happy, ne? You're making me happy. Thank you. JB, ne? All right, Kole, I see you. All right, you're saying that 1.9. Right, let's go and we see a standard galvanic cell is set up as shown below. Yes, man. All right. What are they saying? Which of the following combination of metals used as cathode and electron flow direction is correct? If you look at this, they're saying you need to look at which one is more reactive than the other. You understand? Yes, automatically the one which is more reactive, which is above, it gives out, it is oxidized. So meaning that this one is gonna be oxidized than this. If you check on the reactivity series, let me do like this. Let me open it so that should I need it to, where are you? I say government, where are you? Yes. Okay. Okay. I will open it when it's that time. All right. So if you look at it, you will find out that this is on top, while this in bottom, meaning that this one is gonna be oxidized, so it becomes the anode, and then this one becomes the cathode. And then when they say that metal used as a cathode, automatically this one becomes the cathode. Therefore, that's why B. You see, silver there is the what? And then cadmium is the one which is going to be oxidized. So meaning it is going to release electrons. So electrons are going to come from the cadmium to silver. Therefore, B becomes the most correct answer. Okay, they're saying that when I don't, is it spontaneous? Yeah, we will see it if it's spontaneous or non-spontaneous. Yeah, I'm going there. All right, so you're saying that an electric cell is set up for electroplating in an ion electrode with nickel as shown in diagram below. Remember, guys, this one you don't use the reactivity series. You look at what is positive and what is negative. And the short one means the cathode, while the long one means the anode. So consider the following statement. Iron is, what did they say? What are we electroplating? We are electroplating iron with nickel. Yes. So we are electroplating what? Iron with nickel. If we are electroplating iron with nickel, what does it mean? What does it mean? It means that iron electrode is negative. Yes, and then metal in the solution undergoes reduction. Okay, and then the anode is nickel, pure nickel, meaning that the one which is supposed to release the electrons is the one which is put as the anode. So meaning that Pure nickel is gonna go on the anode, while the one which should be electroplated is gonna go on the cathode, which is iron, and then the metal ions are going in the solution, undergo reduction, so that now the coating can happen. Therefore, the most correct answer here is gonna be what? It's gonna be what? Ne? It's gonna be what? It's gonna be what? They're saying that it's gonna be D. Yes. Huh. Right. Then they're saying that, oh, hey, who got 20 out of 20, by the way? Congratulations if you got 20 out of 20. Ne? Yeah. Anyway, if you don't get 20 out of 20, it's not the end of the life. Remember, I always say that not the best in class is the best in life. Do you think Donald Trump was the best in class? Or do you think our lovely president, Cyril Ramaphosa, was the best in class? Oh man, about Elon Musk, what's the best in class? So, guys, when you go outside there, just make sure that use your brain, make money, be happy, and then life continues. Not about only getting distinctions only. Yeah, get there, make money, be happy. Yeah, you should not be stressed, man. Yeah, even if you got 12 out of 20, yeah, say lema, yeah, you understand. Got it. Someone saying I refuse. All right, let's go to question number 2. All right, letter A and to D to H, the table below represent organic compounds. All right, maybe I should not say that because they will fire me. I won't say it. Yeah. Anyway, that's life, but that's the truth. Yeah, I wanted to say something, but I won't say it. 18 out of 20. Thank you, guys. JB. All right. They're saying that write down the letter that represents each of the following: alcohol, 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 alcohol. Where's the alcohol here? No, 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 no. This is not alcohol. This is not alcohol. Where's alcohol? Alcohol, where are you? Alcohol. Where? Alcohol. Right. So now it must be among these ones. Let me find out the formula. 1, 2, 3, 4. Yes, 4. Uh-huh. Yes, it's 3. Then here, 2. Then 2. OH. CH3, CH2, H. 2, 3, 5, 7, 9, 10. Yeah. Yeah, got it. This is the most correct answer in that regard. Yes, someone got it. A compound with a 4-mile group. Yes, who got it right? 4-mile group, 4-mile group, 4-mile group. What does it mean? It means that is an aldehyde. An aldehyde. Where's the aldehyde here? Aldehyde is here, which is A. They're saying that unsaturated compound with a double bond, compound with a double bond. If you look at here, this has a triple bond. It has a triple bond, a double bond or triple bond. So the answer becomes E in that regard. Yes. Then we go to the next question. We got the next question. They're saying that write down the IUPAC name of B. We go back to B. Okay, B. All right. Let's find 1, 2, 3, 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it's basically the longest chain. So this one and this one, this one, they become branches. So basically it's gonna be hexane. Hexane. So that's the mark. If you wrote hexane, that's a mark. Then I'm saying that now you have 1, 2, 3, 1, 2, 3. So basically, I'm gonna go with the 1, 2, 3. So it's gonna be 3, comma 3 dash bromo, not bromo because there are 2 of them. Yes, di bromo. So then 4 2 methyls dash 4 comma 4 dimethyl, yes, hexane. 3,3 dibromo. Yeah, so they will give you a mark there and they will give you a mark there. How much is there? Yeah, 3. Yeah. So they'll give you a mark there, they'll give you a mark there. If you fail this and you wrote that, they'll give you a mark. Stress, man. I'm stress. Someone saying 5, 6, 3, 7. What's that, man? You mean the arrangement? I don't know. Gaming hub. What is that, man? All right. Gaming hub, thank you for trying at least, man. At least you gave the answer. 3, 4, 3. Yes, man. I see. CJ, I see you. All right. Write down the IUPAC name of compound B. So we are done with that. Then the compound E. Where's compound E now? Oh, this one. They want the IUPAC name of E. So now we have to make it bigger. This is 1. So it's 2. But this one has no hydrogen, and they are putting this in brackets. It means these are branches. So I have that, and I have that. Ne? Wabona. Then this one, I have that. There is no hydrogen in between there, so it means that it has 2. It has 2 of them. And no, 2, 3 of them, because there is no hydrogen at all. Then I have the last one, which is C, and then 3 carbons, 3 hydrogens. So basically it looks like that, but this is not what they want. They want the IUPAC name. So right, let's now start. 1, 2, yes, it's 1, 2, yes, then 1, 2. So basically, guys, what is the multiple choice? Okay, we are done with that. So you guys, now it means that the functional group is here. Yes, the functional group is here. So it's gonna be 1, 2. Then this one is gonna be 1. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So basically, it's gonna be pent. 1, 2. So it's gonna be pent 2 yin. Yes, so it's gonna be 1, 2, 3, 4. So it's gonna be 4, 4 methyl pent 2 yin. Yes. However, some people, they think they wrote they wrote 2. They wrote 1, 2. They said 2, 2. Yes, dimethyl. 1, 2. Dimethyl. 1, 2, 3. Then say 3. Not 3. Dimethyl. Okay. Pent 3 in. Yes. So basically you have 2 of these options. These 2 options are both correct, but this one becomes the most one because it looks to be simpler. Or if you say 2 plus 2 plus 3, 2 plus 2, it gives me 4 plus 3, it gives me 7. Well, here is going to be 4 plus 4 is going to give me 8 plus 2 plus 2, which gives me 10. So this one is a little bit higher than this. Yes. We continue the next question. They're saying that two different. Let me first clean up. Yeah. Right. I'm saying that define the term functional isomer. This one, even if I don't define, you must be knowing. Molecules with the same structural formula but different functional groups. Yes, meaning that they have the same, so not structure formula, yeah, molecular formula, not structure formula, same molecular formula, but the functional group are different. Yes, for example, ketones and aldehydes. Yes, those are functional isomers. Yes, carboxylic acid and esters. Yes. All right, write down the letters that represent the functional isomer. So you have to come here and then look for them. You have to come here and look for them. Where is it? They're saying mm, this is a ketone, and then this is an aldehyde. Yes. This one also looks to be a functional isomer, but we don't know the position whether there is an aldehyde or a ketone. So I can't include G. So I'm going to say E and C. So in this case, I'm going to say E and C. Yes. Instead of G, I can't add G there because I really don't know. Eh, Nancy, what are you saying? You're saying completely wrong. Which one is wrong? Huh? Which one is wrong? What are you saying is wrong? 2 point what 2.2. Yeah, no, my Nancy, no. Okay, they're saying that. They're saying, hey, Nikki is defending, is saying that no man, check the November. Yes, Nikki or Nancy, please. Yeah, check, ne? Yeah. Sometimes we know things, but sometimes when we are marking something different, eh? Yes. That's why we always say that please tell your sisters and brothers to keep themselves on ThunderEDUC. Yes, we will teach you for free. For free. Yeah, G can't be the functional isomer since there's two oxygens. They're saying that I said G is not on. G is not in. Oh man, yes. Good. Yes. G can't be a functional isomer. Cool. So the answer is C is A. Yeah, and C. Yeah, I didn't see the two. Cool. Yes. All right. So you're saying 2.4. 2.4. That's why I like the live classes. Sometimes, ne? Yeah, I like the challenges. Ne? Yeah. All right. You're saying 2.4. If compound F is formed when a carboxylic acid compound F. Now we go back and find what is compound F. Where is compound F? Where is compound F? Where is compound F? All right, we are seeing compound. How many carbon atoms are? 1, 2, 3, 4, 5. Okay, it has 5 carbon atoms. Yeah, they are saying compound F. Right, they're saying that um, formed when the carboxylic acid react with another organic compound. So automatically it is an alcohol. Once they say carboxylic acid react with another, then automatically it is a what? It is an alcohol. Name the formula of the catalyst. Automatically, someone said it already. I saw it, sulfuric acid, but they said name or formula. So here you can write sulfuric acid. Yes, it's a conc sulfuric acid, but they said name or formula. So when they say name, you only say sulfuric acid. But here it's good they said name or formula, meaning that they wanted to give you this mark. Yes, so that's the correct answer. Sulfuric acid. Which type of reaction is esterification or condensation reaction? The structure formula of compound F. Where compound F is formed when? So it means that if you go back here, you look at it and then they say 1, 2. So meaning that the double bond is here and oxygen, and then this one have 1, 2, 3, 1, 2. Meaning that it's gonna be 1, 2 with a double bond oxygen, and then 1, 2, 3. So basically it's gonna be like that, ne? It's gonna be like that. Yes, so hydrogen, you don't forget to put the hydrogens there. There are the hydrogens there, because if you forget, you get a 0 with a tail, ne? Yes, please never forget to write the hydrogens there. Esterification, yes, Robert. Yes, yeah, we said it with esterification. IUPAC name of X. What is X now, man? They're saying that organic compound is react with automatically. They are looking for this, yeah, the alcohol which is formed. Which react with another organic compound X. The alcohol which was used. So in this case, we're gonna say it's 1, 2, 3. So it's gonna be propan 1 or yes, so it is propan 1 or. Someone said propano. Yeah, we prefer to say propan 1-ol because it can be propan 2-ol. Wawana? Yeah, when you say propanol, in most cases, it doesn't show the position unless it's ethanol, because it's ethanol, methanol, whether it's this side or the other side, it is the same thing. But once it starts with 3, yes, you have to show, because it can be here, yes, or it can be here. Wabona? Yes, so that's why we say you need to show the position of the alcohol. Yes, propanol. All right, but if you wrote propanol, I hope they'll give you a mark. Ne? Yes. All right, now let's go to the next question. I'm gonna just 1 second, just 1 second. Yes, still with you. Yeah, I'm back. I'm back. I'm back. Yes, I'm back here. Just wanted to see that everything's moving well. All right, guys, can we continue? Should we move like a bullet? All right, let's continue to the next question. Let's continue to the next question. They are saying that the vapor, question 3, the vapor pressure of different organic compounds are determined at 20 degrees Celsius. The vapor pressure of compound A, B, C are not shown. A, B, C are not shown. Okay, once you know the vapor pressure, then you'll be able to understand the concept behind. Then they're saying that define vapor pressure. So guys, these definitions don't usually, yeah, you must be knowing. They're saying that vapor pressure of a compound A, B, and C are given in random order. All right. Now, if you look at A, what is pentane, then 2-methylbutane, and then 2,2-dimethyl-propane. Yes. So since all of them are they have the same number of carbon atoms, so this is more branched, so it means that it has the lower boiling point and then high vapor pressure. So this one has the highest vapor pressure, then followed by this is medium, and then this one has low vapor pressure. You understand? Yes. So I have to come here and then I say that we'll write down the vapor pressure of C. C is this one, has the highest vapor pressure because it is more branched. You understand? Therefore, it's gonna be this. So what is the vapor pressure? Is gonna be 146. Good. Hope you got it right. Explain your answer, because it's more branched. Yes, meaning that it's more spherical, meaning that it has its bonds are able to be broken easily, meaning that it has a low boiling point, and then this makes it to have a higher vapor pressure. So the way you explained it, as long as it is linked to that, and then it has all the marking points, but that's how you're supposed to explain in that regard. Right, we go to 3.23. All right, 3.3, they're saying compound D and E are compared. Compound D and E. Compound D and E, this is propanoic acid, while this is butanol. What about butanol? Butanol is an aldehyde, while propanoic acid, it is a carboxylic acid, whereby carboxylic acid has the London force, it has the hydrogen bonds, and has dipole-dipole forces. Therefore, its boiling point must be higher and the vapor pressure must be lower. That's why you look at that and then you find it. What are they saying? Which compound has the lower boiling point? Lower boiling point automatically is going to be butanol. Butanol, so meaning that it's going to be E, or if you wrote butanol. Yes, so you get the answer. They give you your mark there. They're saying explain the difference in the vapor pressure. We say that vapor pressure, this one is lower than this because this one has more intermolecular forces of attraction, hydrogen bonds, London forces, and dipole-dipole forces. So which require, while this one has only London force and dipole-dipole forces. So Compound D require more heat to break its bonds, therefore lower vapor pressure, while compound E requires less heat to break its bonds, therefore a higher vapor pressure. So you're supposed to explain in that line. You understand, guys? Ne? Yes. Hey, they say go to question. Man, why are you rushing? Ben, it's not nice to rush when I am fate. Eh? Just want to rush. When you rush, you won't eat things which are cooked. You will eat things which are half cooked. They're halfly baked. You see? You are lucky I'm not in life science. I would have taught you how life is supposed to be, that you don't rush. Ne? You cannot rush. Ne? Yes, you have to be slow and steady. Ne? Yes, all right, let's continue. All right, and I'm not your life orientation teacher. All right, let's continue, guys. Ah, la, 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 la. Yes, night, that's correct. Hmm. Right. Question 4. Study the diagram below. Hey, cracking, forming two organic compound. Hey, now let me see people who know the synthesis. We call this one synthesis. You have organic compound 1. You react it with that. You form this organic compound. So now what is going to help us is this compound and this compound. Remember, when you are cracking, you form an alkane, and an alkene. One. Yes. So if you form those two compounds, so now you need to know which one is an alkane and which one is an alkene. So if you write it is a formula for an alkene. Automatically, this one is going to be an alkane. So this is an alkene. So let me clean it up. So basically, this is an alkene, while this is an alkane. Yes, but they have 1, 2, 3, 4, meaning that even this one have 4 carbon atoms, well, even this one has 4 carbon atoms. Then automatically compound U had 80 carbon atoms. So once you know that, now you're able to do what is cracking. This one is also a definition. Guys, this definition you must be knowing. Yeah. Yes, you must be knowing. Long chains of hydrocarbons breaking down into smaller, useful. That word you must see, guys, you must be knowing those definitions. You can't keep repeating these ones. Yeah. Is the product two primary, secondary, or tertiary alkane? When product 2 is product in reaction to, the bromine is on the outermost carbon chain, meaning that the carbon atom with the bromine is attached to other one carbon atom, or an alkyl group, which means that is a primary alkane. So the answer is primary. Yes, I hope you guys got it right. Structure formula of W. Where is W? W, we said it is what? Yes, we said it is an alkane. Therefore, I'm gonna write it 1, 2, 3, 4. 1, 2, 3, 4, and then you put hydrogens just like that. As simple as eating ice cream, no bonds. Oh, no bonds. You put hydrogens, hydrogen. They're saying write the structure formula of compound. These 3 marks for now. Where are they coming from? Maybe they want you. This one saying yes, prime. Right, they're saying that molecular formula of compound. Guys, let me know in the comment section. I don't want you to tell me stories when I'm out of the studio and then you tell me that, yeah, this answer was supposed to be like this. No, man, I don't want that. Someone is saying plus, 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 plus. No, no. Molecule U, when you go to molecule, yeah, molecule U check. We say that it has 8 carbon atoms, meaning that it was an alkane with the 8 carbon atom. Molecular formula. Here they want the molecular formula. So since it is an alkane, it's gonna be 8H 16 plus 2. Remember, an alkane is CnH2n plus 2, whereby C is 8, N is 8, whereby this 2 times 8 plus 2, which is 16, and then plus 2, so it makes them to be 18. Therefore, this one is gonna become 18. Yeah, who got it right? They're saying the molecular formula. Then they give you. Yeah. When we go, when we say name or formula of the inorganic reagent. Wait, now we organic reagent. Wait. Oh, reaction 2. They're saying name the inorganic reagent because we are forming here and we are from the bromine, we are from an alkane, so we don't add their hydrogen. It's a substitution reaction. Therefore, here is gonna be where is it? It's gonna be bromine. Yes, bromine, or you write the word bromine, or you write that Br2. The two must be there. They're saying that the type of reaction, substitution, addition, or elimination. Yes, because I'm from an alkane and I'm going to haloalkane. 1, 2, 3, 4. Haloalkane. Therefore, it is just a substitution reaction. I'm substituting a hydrogen with a bromine. Yes. One reaction condition. Yes, this bromination, chlorination is more reactive, but bromination, yeah, is more reactive, but it must be under what? Under sunlight. Bromination, no. The chlorination, yes. Bromination, it can take place on its own. Yes, it can take place. Where is it now? Yes, it can take place on its own, or you can heat a bit, or you can put a sunlight. So a bit of heat slash you can put in under sunlight. Yes, or yes, depending on the room temperature a little bit. If the room temperature is a little bit higher, then sometimes we say at room temperature because it can act on itself. Yes, one. Yes. All right, so all these, yeah, it will depend on the markers, and yeah, so but sunlight is 100% fine. Heat is also 100% fine. Room temperature depends on the temperature of the room. If it is you are freezing cold, then yeah, the room temperature may not work. All right, let's continue to the next question. The type, write down the type of elimination in 3. Where is 3? When you come here, you have bromine, and then you form an organic compound. You form an organic compound R. Organic compound R, what is included in R? Yes. Uh, Someone saying dilute base. There is no ethanol here, Buffet. Eh? There is no ethanol. It was from here going there. All right. They're saying that write down the type of elimination. Elimination 3. Where is it? 3 is here. And then you form R. Ne? Isn't it? You form R. So if you are forming R, this is elimination. They're saying elimination. So if you are removing this, therefore is going to become the hydrogenation. Because I'm so here there are two answers you can give. Ne? The first one is dehydrohalogenation or dehydrobromination, because you are removing the bromine. So dehydrohalogenation or dehydrobromination. That's the type of elimination in reaction 3. Yes. Someone is saying dehydrohalogenation. Yes, is correct. Cole Phillips is correct. Or dehydrobromination is also correct because it is the bromine which is being removed, and then you form a double bond there. Compound R and T are positional isomers. Yes, positional isomers. Compound R and T. Where is R? R and T are position isomers. Okay. Compound R and T are position isomers. Yes, okay. Let's find out. What are they saying? If this is a position isomer, so What are they saying? Here, because this bromine is here, ne, on the first carbon atom, meaning that the double bond is going to form here. So it's going to have 1, 2, 3, 4. You understand? So because the bromine is here and then the hydrogen is here, so it means that this is going to lose the double bond there. So if it loses the double bond there, so automatically it's going to be -8. Sorry. Yeah. So it means that the double bond is going to be there. You understand? While here, because they are position isomers, then this one, I'm going to show you how it comes to be like that. You understand? Yes, it's going to be like that. So when this one forms, yeah, this one is the double bond is there, but after that, now we add here the alcohol, which is gonna form here, is gonna be C, ne, C, and then the alcohol is gonna be here now. And then once the alcohol is here, if you dehydrate, ne, yes, if you dehydrate now it's gonna form that. We call this one synthesis of what? Of compounds. Right. So now what is the question? R and position isomers. Okay, they said it. Inorganic reagent shown in are available in reaction 4 and 5. Yes, 4 and 5. All right. They're saying that write down the balanced equation of reaction 4 using the structure formulae and the correct inorganic reagents from above. So basically, guys, here, because I'm going to form from here, I'm going to form an alkyl, I need a base. So here, basically, I'm going to say the structure formula, they say the structure formula. So you guys, you have to write it correctly, ne? CH3, not like this, ne? CH2, is it? CH3, CH2, yeah, CH, ne? CH2. You show all the bonds, ne? And then now I have to add their sodium hydroxide, ne? Yes, meaning that this is the one which I'm going to add so that I form an alcohol, ne? I form 1, 2, 3, 4. So the alcohol now is going to be here. You understand? Yes. The alcohol is going to be here, and then it's going to be CH3, CH2, CH2, CH3. You understand? Yes. So since the alcohol is going to be there, yes. And then now, so I have this, I have this, I have that. So I think they will give you a mark for the functional group, give you a mark for that, they'll give you a mark for that, they'll give you a mark for that. Yes. Then they're saying that the balanced equation for reaction 5 using the structure formula and the correct reagent above. Reaction 5. Where is reaction 5? So automatically, I'm going to just convert now this into, it's the same thing, guys. The same thing, guys. They're saying CH3. Don't forget, let me just do it properly. Let me just do it properly. You know, you people, you're going to say, no. No laptop. Okay. 1, 2, 3, 4, ne? Let me see. 1, 2, 3, 4. Where is it? Where is it? Where is it? This one. Tomorrow I'm writing. Oh. Okay, they are saying that. And then now, what am I having here? The alcohol is here. Is on carbon atom number 2. You understand? So now I want to dehydrate it. I'm going to dehydrate it, but in this case, I'm going to use concentrated sulfuric acid. So here I'm going to put concentrated sulfuric acid because I'm dehydrating, and then at the end of the day, I'm going to have C1, 2, 3, a double bond there. And then, guys, you put the hydrogens where they are the bonds are supposed to be distributed properly. Don't leave these things hanging. You have to write everything correctly and you put everything. So for the sake of time, so I'm not going to put all of those hydrogens. Yes. I think that's it, guys. They're saying the IUPAC name of compound T. Where is compound T now? Compound T, automatically we say that it's like this. Therefore, I'm gonna say 1, 2, 3, 4. So it's gonna be compound T is gonna be 1, 2, 3, 4, which is but 2 in. Yes, but 2 in because it is an alkene. Yes, it's but 2 in. So guys, that is it. That is it. That is it. Question 5. Yeah, we are done with organic. We go to the next question. Hey, sir, why not an alkene? Where? Why not an alkene? The guys, I explained this. That this is an alkane, this is an alkane, and then this is an alkene. Even you see the formula C. You see, it's a formula C. I have 4 carbon and then 8 hydrogens. So I have 3 here, I have 2 there. I have, yes, have a hydrogen there, have a hydrogen here, and have 3 here. So 3 plus 3 is 6 plus 1, 7 plus 1 is 8 to give me that. So this is an alkene, while this is an alkane. Yes, I think I'm now, at least I've tried to. Sir, can't you use hydrogen bromide? No, you cannot use hydrogen bromide because here, where you mean in this reaction, can't use hydrogen bromide? Here, it's not substitution. It's not substitution. We are just sorry. It's not what you're adding here. We're adding a bromide, né? A bromide, which is the bromine. Anyway, it will depend on the examiners, but the most correct answer is bromine. All right. Saying I'm gonna study English. Okay, man. D. Show me where I've done the mistake. Don't say that this man is making mistake. Man, no. Show me where I've done a mistake. Sir, okay, let me check in your messages. We are saying what? Uh-huh. All right. Someone is saying, I think, guys, I'm done with here. Ne? Yes, I'm done with here. So we go to the next question and then, yeah, we smash it. Yes, we smash it. So basically, when I wind up, I say that this is an alkane. I wind up, I say this is an alkane. Yes, this is an alkene. Alkene. Yes, and then we say that this is a haloalkane. Yeah, this one you know. So this one, because we are eliminating, this one because you are eliminating, so it's gonna be an alkene, an alkene, an alkene, alkene, because we are eliminating. And then here, because now I'm adding a strong base, so it's gonna be an alcohol. Yes, so that's how it is. This is an alkene, this is an alkene, but this one, the double bond is in the middle. Yes, while here the double bond is at the end. Yes, it's like that. So guys, there is no stories there. If you wrote it wrong, sorry. Yes, you can't say that I'm writing wrong things. That's it, unless you wrote the wrong one. All right, let's continue to the question number 5. Yeah, someone saying, now, yes, sir, now you are talking. Yeah. Was I crying before? I started working, guy. Yeah, you didn't see. Yeah, you didn't see. And then he said that, hey, this guy is saying wrong things. Hey, you can't say that, man. All right, let's continue. Let's go to the next question. Reaction between pure aluminium. Yes. Now, guys, we need to settle and then we do these questions. Ne? Reaction, guys, there are different options, ne? when I talk about one or two options, does not mean that that's the end of the marking guideline. I cannot talk about each and everything, né? And sometimes there are even others I've not thought of. You understand? Yes. So this is the proposed memorandum. All right. The reaction between pure aluminium and excess hydrochloric acid is used to investigate the factor that affects the rate of yes. The balanced equation is down. All right, this and this and this and that. All right, define the rate of reaction. Guys, you know the definitions. I don't need to go too much here. But basically, you have to talk about the concentration of the product and the concentration of the reactant, how they are changing, and then they are changing as the time also is changing, meaning that per unity time. So, in this experiment, okay, you have this react with this. All right. In the strip, okay, the graph below shows the experiment in the scale. All right, for the time interval t1, guys, let's not argue too much here because there are different methods you can use. Ne? There are different methods you can do what you can use. Yes. Then they are saying that different methods. Let me bring my calculator. I think let's just do. One of the methods they're saying that the time t is this at 0, time t is 0, and time 5 minutes. The average rate of action, the average rate is equal to this. Okay. Now they are saying that calculate the mass of aluminium present in a container at 5. We are looking for the mass of aluminium that is present in the container at 5. Okay, let's calculate. What is the first step? Okay, they gave us this, right? And then we need to calculate because this is the what was given, né? But this reaction is still continuing. So it means that there is a mass which was used from here up to here. You see? So if there is a mass which was used from here up to here, what does it mean? It means that there is how much mass is taken or is used per unit minute, per minute. Because they said here the rate, the average reaction of hydrogen, okay, meaning that how much hydrogen is formed per minute. Meaning that here I need to look at per minute. This is what is used. How many minutes do I use? I used 5 minutes. You understand? So now I need to know to find out the number of moles. Remember, moles is equal to, yes, is equal to what? Is equal to, let me use volume over molar volume. You understand? Whereby, because they said it here, aluminium, okay, at room temperature. All right, so now I'm gonna say that if number of moles, I need to find the number of moles which reacted, yes, which formed for this, and then I compare it with the hydrogen, sorry, with the aluminium, and then after that I subtract so that I get the remaining one. So meaning that here number of moles is equal to volume. The volume in this case, I'm talking about the volume of hydrogen, yes, of which I'm gonna equate it with this decimeter. This is the volume, so it's gonna be 0.033. That is per minute. But how many minutes do we use? We use the 5 minutes, so I'm gonna say times 5. You understand? Meaning that I know now the volume of each minute I use this, I produce that. But after 5 minutes, I'll produce this because they say the average. Yes, so meaning that now divide by the molar volume. The molar volume of hydrogen at room temperature is 24 decimeter cubed. So you go and then check from there, né? From the Then after that, I will need to know the number of moles is going to be when I calculate. You can calculate if my calculator is not right. 7673 times 10 power negative 3. So these are number of moles, yes, of hydrogen which was produced at 5 minutes. So now, since I know the number of moles of hydrogen which was produced at 5 minutes, yes, so what am I going to do? Yes, what am I going to do? So what I'm going to do, I'm going to say that hydrogen to aluminium. How many hydrogen do I have? I have how many? I have three hydrogens. Have three hydrogens. And how many aluminiums do I have? I have two aluminium. So now I need to know the number of moles of aluminium. I need to know the number of moles of what? Aluminium. Yes. So now I'm gonna say to convert, meaning that this number of moles are for hydrogen. So meaning that is gonna be 6,7 3 times 10 power negative 3. Then I'm gonna call this x, whatever. Yes. You multiply. So meaning that it's gonna be 2 over 3 times this. So the number of moles is gonna be, you can say 3x is equal to 2 times 6,73 times 10 power negative 3. Wabona? Then divide by 3. That's why I said 2 over 3. Yes. Then x is going to be giving me how many moles? How many moles, guys? If I calculate, my calculator is not right, you tell me, because I'll end up getting the last correct and the last figure as wrong. But if it is right, as long as the method is correct, that's how. Yeah. So now these are the number of moles. Yeah, these are the number of moles. Yes, those are the number of moles of what? Of aluminium that was produced. You understand? Yes. So now I need to convert the number of moles into mass. So let me convert the number of moles into mass. So mass of aluminium is gonna be equal to, remember, number of moles from the is equal to mass over molar mass, isn't it? Yes. So which meaning that the mass is gonna be equal to number of moles times the molar mass, of which I have the number of moles, which is 4,49 times 10 power negative 3. Yes. Times the mass from the periodic table, yes, of aluminium is 27 times 27. Wabona? Once I get 27 there, so the answer here, when I multiply, I'll get 0.121 grams. So these are the number, this is the mass of aluminium which was used. Guys, do you get it? Yeah, that is the mass of aluminium which was used. But I started with this. So meaning that this is the one which is used, so I need to subtract and then I get. So basically, I'm going to say mass of aluminium which is remaining, yes, which is remaining at 5 minutes. Yes, aluminium remaining is going to be 0.5 minus 0.121. Then the answer I get is 0.37 grams. So that is what I get as what is remaining. Thank you so much, guys, man. Yeah. But guys, don't forget that even if you don't get the correct answer at the end, they will give you all the steps. I'm telling you, you must not be stressed. Yes, you must not be stressed. Let's go. Then we go to the next question. We next go to the next question. Use the collision theory to explain in the reaction rate. T is equal to, okay. Here they are looking. This one is an explanation of which I'm not going to explain that much. At 0, you have a lot of reactant. At 5, the reactants have reduced, meaning that they have converted into products. And then it means that the number of particles that are reacting or colliding to form for effective collision have reduced. They keep on reducing. At 5 minutes, the number of particles which react to form a product, meaning that effective collision per unit time, have reduced. Therefore, the rate of reaction is gonna reduce. So basically, you explain in terms of that. Yes. So I'm not going to. I need to do most of the calculation. Redraw the graph. Okay, they're saying that the booklet, and then on the same axis, draw the curve that obtained experiment 2. Label it B. Experiment 2. What about experiment 2? What is experiment 2 now? Oh, experiment 2, they're saying they're using 2 moles of this instead of what? What did they use? What did they use? They used 1 mole. So basically, but don't forget, guys, this is hydrochloric acid. They said it is in excess, meaning that it's not going to change any final product. What it's gonna do is gonna increase the speed at which it is reacting, but does not going to form the final product at a higher level, unless it was not in what it was the limiting factor, because the calcium, no, aluminum is going to finish, so it is acting as a limiting reagent. So if this is the first graph, so it means that they must have the same end point. So this is A and then this is B, meaning that it's going to shift to the left, meaning that more particles reacting are going to be available. So meaning the more effective collision, and then the reaction rate is going to increase. But because of the aluminum is still the same amount and it's the limiting reagent, or limiting reagent, then automatically the reaction is going to form the same product, but it's going to complete faster a bit. So it means that you just had to draw it towards the left, towards this side. Yes, I think that's it. Experiment number 3. Then they are saying experiment number 3, experiment is repeated with this one now. Pure, yes, it's the same amount, but in this case they are doing the same the powder. Still, the product is gonna be the same because they didn't change the amount of grams of aluminum, so it's gonna be the same thing. Therefore, I'm gonna say what? I'm gonna say aluminum is gonna give me aluminum what? It's gonna be giving me, so when I draw, this one is gonna be that, then the reaction still is gonna be like the same way, but now it's gonna be a little bit faster. So what are they saying? How will the volume of, they're talking about the volume of experiment 3 compared to that of experiment 1, greater, equal, or it's gonna be equal. Why? Because it's the same amount, but the rate is gonna be faster. The rate is gonna be faster. Yes, the rate is gonna be faster, but the end product is gonna be the same. So what are they talking about? They're talking about the volume of hydrogen which is formed. So it's gonna be the same thing. Yes. Right. We go to the next question. They're saying that X is Maxwell distribution curve for the reaction under the set conditions. A change was made to one of the reaction conditions to obtain Y. Right. What change made to obtain Y? So basically, if you look at it here, this is the moment you have this, and then this one comes in, so it is the temperature. So in this case, what was do here, it is the temperature. It is the what? It is the temperature. So here the answer is temperature. Yes, meaning that the temperature was increased. Temp increased. Yes. Give a reason for your answer. Yeah, you see that more particles now they have. If this is the EA, meaning activation energy, you'll find that more particles now will have sufficient energy to form products. Yes, guys, pressure decreased. You can talk about pressure when you have aluminum, because aluminum is a solid. Yes. Remember, pressure only works in gases. We go to question 6.1. Question 6.1. What is it involved here? The reaction of carbon monoxide with the Oxygen is investigated in the reaction reaches equilibrium in the closed container at this. All right, they're saying that the change in the condition of equilibrium are made at different times. The graph shows the results X, Y, and Z represent a gas in the above reaction. All right, define chemical equilibrium. This one is also a definition. I don't need to define that too much, but basically don't forget that uh, 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 chemical equilibrium, the rate of forward reaction must be equal to the rate of the reverse reaction. Yes. And they're saying that at T1 oxygen was added. In this one, yeah, at T1 oxygen was added. And the container, write down the letter that is responsible for oxygen. Choose X, Y, and Z. Choose X, Y, and Z. Oxygen was added, meaning that this is oxygen because you see there is a sharp increase. So the answer here is X. At temperature 2, pressure is adjusted by changing the volume of the container. And was the pressure increased or decreased? So now I need to find out. I have 2 plus 1, meaning that this side is 3, and then here I have 2. So the forward reaction is favored by increase in temperature, while the reverse reaction is favored by decrease in temperature. But now this is a product. This is the reactant, you see? Yeah, it's a reactant, and also this is a reactant. But when it reached here, it reversed. You see? It reversed. Now this one becomes the product. You see, product, and then also this one becomes a product. Yet this one was a reactant. You understand? And also this one was a reactant. Are you seeing? Yes. So it means that now reactant, product. So and then now it becomes reactant. Basically, now the reaction is going reverse. Here the reaction is going forward. You understand? So meaning that here the answer here comes in, and then we say that the answer becomes here, and then we say that was the pressure, meaning that now the reverse reaction is favored by decrease in the pressure. So the answer here decreased. We say that the pressure decreased. Explain your answer. Because yes, the reverse reaction is favored by increase in what? In the pressure. Yes, because of this one has 3 moles, while this one has 2 moles. Write down the name or formula of the gas that is represented. Name of represented by Z. Z automatically, because this was a reactant, and also this one was also a reactant. And then here reactants, how many do we have? It means that this is carbon monoxide. Yes. And then now, because this is a product at the beginning, so this is carbon dioxide. So meaning that Z, name the formula or a gas that is represented by Z. It is carbon monoxide. They said name or formula, so you say carbon monoxide. Yeah. Then they're saying give a reason for your answer. Yes, it is the second reactant. You see, it's the second reactant here. It depends on which explanation, the way you explained it, but it's a second reactant here because the first reactant is already taken there. Number 2, if you look at the number of moles, it requires 2 times. This is 2 times, while this one requires 1. You understand? Yes, this one requires 2 times to make this one. It's 2 times to this. Yes, 2 times to that, you see? Yes, so you can also explain that case. Carbon monoxide. All right. Someone is saying 0.5 out of 150. How can you say that now? Well, yes. How? What? All right. They're saying that now use the what change in temperature is made at T3. Hey, guys, here, this question is tricky. Listen carefully. This question is tricky. They're saying that what change is made at T3. Choose increase or decrease in terms of temperature. Guys, look, when we go back, we say that if you're following the same reaction, if not what happened here, because we keep moving. No, you understand? The forward reaction here, they say that is less than what? It's less than 0. Meaning that this reaction, the enthalpy change is less than 0, meaning that it is an exothermic reaction. You understand? Don't say increase. Hey, you're gonna say increase or decrease. Yeah, I'm telling you, it's gonna shire you. So is the enthalpy change is less than 0. Wabona? So if meaning that it is an exothermic reaction. Exothermic reaction are favored by decrease in temperature. Wait, decrease in temperature. But listen carefully. They reverse the reaction here. You see, they reverse. This is the reverse reaction. They reverse the reaction. This is the reverse reaction. Meaning that now it's moving this side. Meaning that this reaction is exo, this one is endo. Wabona? So now, and then when it reached T3, again, remember this is a product, now it is going down. Meaning that now, again, it has reversed. Meaning that this one now is exo. Meaning that what made the endo to reverse? The endo reverses by decrease in temperature. Yeah? Yes. The endo. Remember, exo, this one is endo. When you increase the temperature, you are favoring, meaning that this reaction wouldn't have reversed if you increase the temperature. But now you decrease the temperature, it's gonna favor the exothermic reaction. So meaning that that's why this reaction now reversed. Are you seeing? I don't know whether you see what I'm saying. This reaction is gonna, you see, this reaction, it was like this. This is a product, you see, but now it's a reactant. This was a reactant, now it's a product. It means again it's reversed, meaning that this is now exo is coming from endo. So to change from endo to exo, you have to decrease the temperature so that now more heat is produced, meaning that here it is decreased the temperature. Guys, I think you got it. I'm sorry if you wrote increase. Anyway, the markers will see. I think this one, they're saying use Lexinian principle to explain the answer. Yeah, I've explained it, that this one is being favored by decreasing temperature. Therefore, the reverse reaction is gonna be favored. That's why you see that now this one, the reaction what? It reversed. All right. Let's go, guys, to the next. It's 9 marks, but these people. Why really? Why? Why? Now, if a kid doesn't know, he's gone. All these 9 marks. Anyway, I'm not the examiner and I can't say anything. Just watching and all right. But when I saw that 9 marks, I was so sad and say, "Oh my God, why this happening like this?" Anyway, let's continue. All right, they're saying carbon monoxide react with water vapor, all right, and then the reaction reaches equilibrium according to the balanced equation. They're saying that initially you have this, and you have this, and you have this, you have this. Yeah, since this one is all is the same one mode, automatically also here I have that. You understand? All right. So because of that, now I need to understand what is behind that. You understand? Yes, I need to understand what is behind that. So I'm saying that someone is saying, got what? I know you guys, you got these marks. I know you guys, you got them. I'm telling you because I trust you. All right. Now, what we need to do, we need to find out. Let's first draw our table and we see what do we have and what don't we have. Let me just make it bigger. Start it from here and then by the way, don't forget to subscribe and like and share. Yes. So basically, I have what? I have carbon monoxide. I have I have water here. I have carbon dioxide. I have hydrogen here, isn't it? So now since I have that, then I'm gonna use my rice method. You see? So let's go to our rice method. So mole ratio is 1, 1, 1, 1. So that one is initial. Initial is say that it's 0 0.6, 0 0.6, 0 0.6. Is it 0 0.6 carbon monoxide? They say the initial moles of carbon monoxide. They're saying initially carbon monoxide moles. Okay, I'm saying 0 0.6, 0 0.6, and then here is 0 0.1, 0 0.1. But now once I put them like that, I'm gonna get stuck because these are number of moles. So I don't know what is next because they only gave me this. So what is next? So I think you guys, some of you, when you reach there, you also got stuck. But let's find out. Let's find out. So what we can do is now we're going to have to change from moles and then we use concentration. Remember, when we have been busy teaching you guys, I said that sometimes they bring concentration. So let's convert it into concentration. Moles per decimeter cubed. So since I have moles per decimeter cubed, yeah, you can use the same, still the same style, and still you get the same answer. Yes, meaning that you can say, okay, this is negative x. You see, you can say that negative x. You can say even here it's negative. It's gonna be negative x, and then here is going to be positive x. This one is going to be positive x. Yeah, because it is 1 1, yeah. But now because when I reach here down, it's going to be too much for me to divide with the more ratio, sorry, with the decimeter cubed. So what I'm going to do, I can first I use the decimeter cubed, meaning that I'm going to use moles per decimeter cubed. So let me say that carbon monoxide moles is C6. So let me put it into moles per decimeter. So divided by the molar volume, which is 2. So it's going to give me 0 0.3. Now this is going to be moles per decimeter cubed. You understand? So that is easy. So that I eliminate this. I eliminate the last part here, which I'm going to use to substitute in the other formula. Yeah, but even if you go like this, you can still get the answer. Ne? Yes. Then I go to water. Water here, it is 0 0.6 still divided by 2, so it's going to be 0 0.3. Then I go to 0 0.1, which is the carbon dioxide. It's going to be 0 0.1 divided by 2, which is 0 0.05. Then I go to even the other method you can use it, né? Yes, it's still fine. But if you are not that strong in maths like me, yeah, it's better to use this. So it's going to be hydrogen, which is 0 0.1 again, divided by I2, which gives me 0 0.05. So meaning that, guys, instead of using these moles here, I'm going to use what I've got here. Yes, you understand? So that I prevent that T dividing by 2 because it's going to become more complex. Yes, so 0 0.3, 0 0.3 is here, and then 0 0.05, 0 0.05. You see? So now what is remaining is this minus this. You understand? It's the same thing. So now I'm gonna say 0 0.3 minus x, 0 0.3 minus x, 0 0.05 plus x, because it is we started with this, né? 0 0.05 plus x. You see? So now people already giving me the answers, and I know you guys got. Hey, you guys, you make me proud, ne? You. Yeah, your answers are correct, but I want to show the people how did we get that. Thank you so much, guys, ne? You make me feel good, ne? You make me feel good. All right. So now, after that, since now I have this, I don't need to divide it by decimeter cubed because I've already divided it here. You understand? So I just go here. Kc is equal to the concentration carbon dioxide, and then hydrogen, and then I'm gonna say carbon monoxide, yes, and then I'm gonna say H2, H2O. Hey guys, why did we add H2O? We added H2O because here they say it's a gaseous form. If it was a liquid, then you remove it, leave it out. Meaning that this is just a steam. Wabona? Yes. So now from there, since I have that Kc is equal to 4, now I'm going to substitute. I'm going to bring this here and I say that, I'm going to say that 0.3x ne 0.3x, yes, into 0.3x. wabona it's not 0.3x. I'm giving the I'm starting, I'm giving the, sorry man, these ones ne 0.05 plus x, yes, into 0.05 plus x ne plus x wabona, yes. Then divide by 0.03. Is it 0.03? 0.3, not 0.03. Yes, 0.3 minus x, yes, into 0.3, yes, yes, minus x, yes. So you understand, this and this is equal to squared, isn't it? So it's like 4 is equal to 0.05 plus x squared. Also this one 0.3 minus x squared is the same thing, isn't it? So once I get that, I can square root them. It requires people who know how to do the maths. Me, I'm not good in maths. So this one they cancel, meaning that I'm gonna come back here and I say that I'm gonna come back and I say that 2 is equal to 0.05 plus x, yes, divide by 0.3 minus x. So I can say 1 and then you cross multiply, and then from there I can say that 2, yes, in two brackets, and 0.3 minus x, yes, close the brackets, minus, no, is equal to 0.05 plus x is equal to this, this is equal to this, yes. So basically here I'm gonna have 0.6 minus 2x is equal to 0.05 plus x, isn't it? Plus x, yes. So now I will get 3x, yes, is equal to 0.6 minus 0.05, isn't it? Yes. So basically if I divide, yes, if I divide, what am I going to get? It's gonna be, if you divide, you subtract there, you'll see that 3x is equal to 0.55, yes, because you take this one this side, you bring this one this side, yes. So divide by 3, divided by 3, so x is going to be equal to 0.1833, yes, 33, yeah, that's the concentration. So since I have that, it means that now I can substitute in x. What are they looking for? Calculate the concentration of what? They want the concentration, what do they want? This thing is too much, yeah. The mass, but I need to find out the concentration of what? The mass of carbon monoxide. The carbon monoxide is here, you see. So now it means I'm going to just bring that here. The concentration of carbon monoxide, there's no 2 there, is equal to what? 0.3, 0.3, yes, minus x, of which x is 0.183, yes. So when I subtract, I get 0.117 molar. So since now I know that, yes, now I know that this is number molar, so I need to get the number of moles. So the number of moles is equal to CV, yes, of which I have the number of moles, I don't have the number of moles, so I'm gonna say number of moles is equal to this 0.11 molar times the volume, which is 2, which the volume of 2 which was given here, the volume of 2, here it was given here, so it means that I'm able to get that. So the answer number of moles here is going to give me as 0.234 wabona moles. So since I have moles, now I'm going to say that molar mass, molar number of moles is equal to mass over molar mass, of which number of moles I have, isn't it? So what I'm going to say, I'm looking for mass, so I'm going to say mass is going to be equal to number of moles times molar mass, of which mass is now is going to be equal to number of moles 0.234 times molar mass of what? Molar mass of carbon monoxide. Carbon monoxide, carbon is 12 and oxygen is 16, which gives me 28. So times 28 here, when I calculate, end up mass is equal to 6.552 grams. So if you got 6.5, 6.4, 6.5, whatever, well, I think you'll get the answer. 6.6, I think all of you will get the mark. Guys, but this people who don't do maths, I don't know. I'm sorry, guys. Ne? Same man. Congratulations, you guys, you got that right, or you managed to get it right. Ne? Yeah, thank you so much, guys. Ne? Yeah, you're making me proud. I see that I'm gonna have more doctor and yes, someone saying that I nailed it. Thank you so much. Ne? Thank you, precious. Thank you, thank you, thank you, thank you. Ne? Yeah, I see you, JB. Exactly. Thank you, thank you, thank you, thank you, guys. Ne? Yeah, you make me more happy. You remember I told you that when you give me these simple reactions that you are very getting them right. I see that we're gonna get more doctors, and it makes me happy. It makes me happy. It makes me happy. All right, let's continue, guys. By the way, don't forget to subscribe and like and share. Someone is saying that 6.44 is correct. I think it's correct. I said 6.4, 6.5, whatever. Even if you don't get it right, you get the rest. Maybe you get 8 out of 9. Still is very good mark. Yeah. So guys, don't stress. I know that you will get the mark. All right. What is a weak base? Question 7. How many questions are we having? Still have a lot of questions. I need to sleep, guys. Don't want to sleep. Ish. But it's nice. It's nice when you see that the paper is flowing. Yeah. 7 killed me. Rio de. Don't say that. I know that you're gonna get it right. Ish. Question 7. Yeah, let's try and then you see how we can also smash it. You never know, we will smash it or it's gonna smash us. Yeah. All right, they're saying that hydrate potassium carbonate. Guys, there is a lot. I always say that there is a lot of methods you can use. Even the one for Casey, there is a lot of methods you can use. You understand? So, you need to find out the best method. You understand? Yes. So let's try and see. Maybe what I've used might not be the same you have used. You understand? Yes. So if the answer is just a little bit small or just alternating just small bit, you just know that maybe your answer is still correct because of the rounding off and stuff. It can also be a reason why you don't get exact answer. Right. Potassium hydrate potassium carbonate, or this is a weak base, okay, is a solution prepared by dissolving the same in water. Define the term weak base. Weak base is a substance which partially ionizes when it's dissolved in water. Yeah, it's basically it doesn't dissociate. Did I say ionizes? Dissociate. Because ionization is based on the acid. Dissociate partially when it's dissolved in water. Yeah, that's the definition. I don't usually talk about definitions. You're supposed to define themselves yourself. Okay, write down the formula of the conjugate acid of the C, conjugate acid of a carbonate ion. In most cases, guys, you see this carbonate when it is reacting. Remember, this is a 2. In most cases, when it is reacting, it reacts slowly. Yeah, it reacts slowly. So basically, a carbonate, if you have a carbonate, If you have a carbonate, you convert it into, it first go into hydrogen carbonate, you see, and then the hydrocarbonate then converts again. It keeps on adding until it's either from a carbonic acid, so it keeps on reducing and reducing. So basically, what they are looking for, they were looking for this. This is its conjugate. Conjugate what? Conjugate. Conjugate acid. Let's go to the next question. They're saying that someone saying hydrogen ions. Hydrogen ions, I don't know whether they'll give a mark, but remember it keeps on ionizing. It keeps on ionizing until, actually this is supposed to be like this, until it forms a real carbonate. You understand? Yes, it keeps on reducing one hydrogen, yeah, until the whole hydrogens are gone. You understand? You see, when you look at these equations, they don't react the way you think they react. They keep on reacting in bits. The same way you see like sulfuric acid. Ne? It doesn't, if it ionizes, doesn't ionizes just the way you see it here. No, it first change into this sulfuric acid. It first changes, then you see that it changes from sulfuric acid, one hydrogen is lost, and then you're gonna form this, a negative, you see. Then after that it keeps on reducing, and then it reduces another until now this one, it will come here. Yes, so you see where the conjugate acid comes from, so it becomes the conjugate acid, you see, and then now it ionizes completely to form the sulfate, you see, then plus the hydrogen. So it keeps on reducing one, most especially if it is a diprotic acid. Yes, so it's the same story here. When you look at the carbonic acid, it's the same story that happens there. Anyway, let me not take too much time there. Let's go to the next question. They're saying that hydrochloric acid was this titrated with potassium carbonate solution, unknown concentration. We don't know the concentration. Now they're saying define the value of this. Okay, this one is simple. Guys, this one is simple because they said volume used. Yes, that's the volume used, that's the pipette, so we don't count it. So you need to look at the burette when you are titrating. The burette initial reading is this one. The final reading we don't know, but this is the volume of the thing used, so it means I'm gonna say 6,5 plus the volume used, which is 20,05, and then I get the answer, which is 26,55. So that is the answer for P. And then for answer for Q, so this is the final, so I'm gonna say 48,3 minus 20.15, so I get the answer as 28,15. So that is the answer for Q, meaning that's where we started, plus this. Yes, and then when you subtract these two, you get this. Yeah, so basically this is that is it. Then they're saying that methyl orange is used as indicator. Explain methyl orange is most suitable indicator for this titration, referring the pH of the equivalent point. Basically, methyl orange it basically turns pink when it reaches the equivalent point. But why is it used? Basically, methyl orange used when you are testing the weak base, a weak base, and a strong acid. Do you have a weak base here? Yeah, you have this is a strong acid, and then they say that it is a weak base. They said it. They said I saw it somewhere. They said you see, potassium carbonate is a weak base. It's a weak base, so meaning that it's a weak base, strong acid. That's why methyl orange was used. Right, guys, someone said P is 13. No, my brothers. CJ, no. I think this one was required for you to go to the laboratory and then do the practicals, and then you see exactly what you're supposed to do, because this is a titration from the laboratory. Yeah, the pipette, you see the pipette, you berate, yes, you subtract. Right, the concentration of potassium nitrate. Yes, now here there is a simple, let me see if the space will be enough for me. If the space is not enough for me, I'll see what I can do. I'll create another space. Okay, they are saying that 5 point, let's go to the next question and then we see what we get from there. 5 marks. Here I use two different methods. I can use the method where I use the formulas, or I can use the first principles. So I like to use the first principles because when you go to the university, you use the first principles. But I'm not going to use this first principles because you guys, I think you are used to the formulas. But remember, still you have different formulas, different styles. You can do it as long as you move in step by step. Remember, the marking guideline has different ways in which it can be used to mark your answers. So don't stress when you see that things are not going to your you are not going to your answer, you are not going to your yes. But since you you guys, why are you doing this to me? When I see CJ, why are you giving the answers before I say anything? Okay, let's see if we're gonna get it. Let's see. All right, let's start. They're saying that methyl orange is used as indicator. Explain why methyl orange is most suitable indicator for, okay, we're done with that. Calculate the concentration of, so now we need to know, we say that potassium carbonate is equal to potassium carbonate. Let's find out which volume did we get. So now the first of all, we need to find out the volume which we got. Potassium carbonate is here, but now remember, when you are calculating the volume here, you need to get the average. So I'm going to say 20,05 plus 20,15. So plus the 2 divided by the 2 so that I get the average. Yeah, so if when you get the average is 20.1 cubic centimeters. Remember, these are still in cubic centimeters, which we need to convert them into. Yes. Then we go to, we need to know now, what did they give us? They want the concentration. Do we know the concentration of this? We don't know. What else did they give us? They gave us the hydrochloric acid. Hydrochloric acid, they say that is 0.1 molar. They said it here, they said it's 0.1 molar, so I say 0.1 molar. And then the volume of hydrochloric acid, they said it here is 25 cubic centimeters. So I'm going to say 25 cubic centimeters. Yes. Are you getting that, guys? You are not going to don't worry, you're gonna get the answer. Don't stress. If you skipped that, still you can get the answer. If you used this just like that, still the answer might be just there. You understand? Still you'll get the marks. As long as you did the correct substitution and stuff, still is fine. You get marks. Don't stress too much. Yes. And then they're saying that, so this is what we have. So now we're gonna use what we have and then we get what we don't have. You understand? Yes. So now we have this. So in the first principles, we're gonna use this, we get this, we compare it with the mole ratio, then that will be equal to this, and then I find in the 1000, and then I'm able to get the concentration. Those are the first principles. But if you use your style, let's use your style. Now let's use your style and then find out. So first of all, I need to find out the mole ratio of this potassium carbonate to hydrochloric acid. We give you a mark because if potassium carbonate, we come back to the equation, it is 1. This is 1 and then this is 2. Okay, so this we give you a mark there, yes. And then now after that we can use your method. The method, because it is, I don't know whether it's there on the paper, but if it's not there, still is fine. The one which you say that n acid over n base is equal to C acid over C acid over C base over V base. Do you understand? So now once I get you, they give you a mark there. You see now 2 marks are gone. Then now we come here and then we say that now we substitute. You have to have correct substitution. So obviously of the acid is 2. It's going to be 2 over this one now over 1, so it's equal to the concentration of the acid, of which we don't know the concentration of the acid. Do you know the concentration of the acid? Yes, we know the concentration of acid, which is 0.1. Yeah, we know the concentration of acid. Do you know the volume of the acid? Yes, the concentration of acid is there. The concentration of the volume of the base is so times 25, but 25 is cubic centimeters, so I need to convert them into 1000 US. You understand? Divide by now the base. I don't know the concentration of the base, but I know the volume of the base, which is this. So it is 20 times 20.1 divided by 1000. You see? So now I get the answer there. I get the answer there. So now from there, since now I know that, I'm gonna cross multiply. This one goes there and this one goes there. So basically, at the end, I'm gonna have 0.0402 CB. This one, you see, because now this one I converted them, ne? Yes, CB. I have to convert it. So 0.02, so okay, times CB, yes, divide by divide by 0.0402. Okay, let me just first do it like this so that it is clear. Let me just do like this. You're saying that 0.0402 CB is equal to 2025 times 10 power negative 3. Yes, when you calculate here, ne? Yes, and then you multiply it by that. So basically divide by 0.0402 divided by 0.0402. So CB is gonna be equal to what? CB is gonna be equal to 0.062 molar. Are you seeing? Yes. So basically that is that. Yes, guys, I think you are getting it right. Yes, do we have people who got it right? Yes, hey, people got it. Magnesium at 225 cubic centimeter. Hydrochloric acid reacts with magnesium at 25 degrees Celsius according to the following balanced equation. So they're saying that magnesium plus this, you get this. Use the oxidation number of reactant. Okay, explain why this reaction is a redox reaction. So if you look at this, what is it now? This is magnesium. It has 0, but when it reaches here, it has Mg2. Wabona? Yes. And then this is hydrogen, which has +1. When it comes here, it has 0, meaning that this is oxidation while this is reduction. So it involves both oxidation and reduction. Use the redox reaction number, explain why this reaction is a redox. Yes, you see that magnesium starts from 0 and then it goes to +2, while this one starts from +2 and then it goes to 0. So it is a redox reaction. Write the formula of the oxidizing agent. So when you talk about the oxidizing agent, what are you looking for here? Oxidizing agent. You need to look at the one which reacts more. Ne? You need to look at where you write down the formula of the oxidizing agent. Oxidizing agent, it means that it is reduced. Did I say you use the okay? Write down the formula of oxidizing agent. The one which is reduced, it started from +1 to 0, meaning that hydrogen becomes the oxidizing agent. Hydrogen ion, and they say the formula, they don't want so you have to write it as that. They are saying that it is observed that dilute hydrochloric acid does not react with the copper. Dilute, okay, at 25 degrees Celsius. Dilute hydrochloric does not react with the copper So strong, yes. So basically what you need to look at here, if you look at why does the hydrochloric doesn't react with the copper, because basically magnesium is a strong reducing agent than copper. You understand? Magnesium is a strong reducing agent, meaning that it can be oxidized easily than copper. So by what oxidizes it? It is hydrochloric acid. So if you put here copper, it won't be able to be reduced. Yes. So now they're saying that we can say that since magnesium is a strong oxidizing, is a strong reducing agent than copper, therefore hydrochloric acid cannot oxidize magnesium, but hydrochloric acid can oxidize magnesium because magnesium reacts more, but it cannot oxidize copper. Why? Because copper is not readily lose electrons to hydrochloric acid. Do you understand? So that now once it loses electrons, it forms that. So basically you can you're supposed to explain in that regard that one is more reactive, one is less reactive. Therefore copper cannot is not readily able to lose those electrons to hydrochloric acid. Explain your observation. They're saying, okay, so I've explained that. They're saying that will dilute nitric acid react with copper at nitric acid always react. Actually, is most especially almost everything because yes, actually is one of the most soluble acids. Yes. Nitric acid, the answer is gonna be yes. Yeah, will nitric acid react with the copper? Yes. You have even a copper nitrate. Yeah, it is easy to find it there. Yes. uh, what about copper chloride? Copper chloride is there, but is in most cases it is not that soluble. Explain the answer in terms of relative strength of oxidizing agent. Yes, nitric acid is a more strong oxidizing agent. Yes, than even hydrochloric acid is a more oxidizing agent. Yes. Yeah, is more oxidizing agent. Yes, meaning that it can oxidize the copper easily. You understand? Yes. They're saying a galvanic cell is represented. These ones I just explained. A galvanic cell is represented by the cell notation. All right. They're saying that write down the balanced cell net ionic equation for this reaction. So now let me see what they're saying. Let me see what they are saying. That okay, so it means that this gives this. So it means that this is reactant, this is product. This is reactant, this is product. So if you are writing the reaction, is gonna be lead, yes, solid plus now this reactant with this reactant plus F iron 3 gives me lead 2 or lead 2, whatever, plus iron 2. Wabona? Yes, but now it's not enough because here I have 3 and then here I have 4. So what I need to do is I have to balance them so that it is balanced. So this is 6, this is 4 plus 2, this is 6. So it means that the equation is supposed to be like that. We put this aqueous, this is aqueous, and then that is aqueous. Yes. Then they're saying that how will the effect of EMF of a cell choose from okay, a strong oxidizing agent is now used at the same oxidizing agent under the same condition. If the strong oxidizing agent is used, then automatically the EMF is gonna increase. So basically I'm gonna say it will increase. Yeah. Guys, I'm tired. Oh, it's the last question. All right, let's go to the last question, guys. They're saying that a strip of silver is added to 1 mole decimeter cubed of solution of lead nitrate at 25 degrees Celsius. All right, so they're saying that consider the reaction below. All right, I was supposed to use the reactivity series, but guys, the time now. All right, they're saying that consider, okay, so you have silver, you have lead, okay. By means of calculation, determine whether the reaction is spontaneous or is non-spontaneous. Remember, if you get a negative value of EMF, it is non-spontaneous. If it is positive, it is spontaneous. So since now here you look at which one is gonna be on top, you understand? Yes, which one is gonna be on top. Then they're saying that silver is added to this, and then okay, consider the reaction. All right, by means of it. Okay, so if you look at this equation, so we're gonna follow the equation. If you look at this equation, you see that silver oxidized to this. So this is oxidation. So what does it mean? It means that this is gonna be the anode. Hey, it was supposed to be the cathode because lead is more reactive than silver. But since they said it like that, and then this one is reduced, you see, now it's gonna be cathode. This thing is gonna be, you see. So now once it's like that, now I come here and I say E cell is equal to E reduction minus E oxidation. So E cell is gonna be I have to go and look for silver. Where are you? I usually tell my kids to use the B. Silver, where is silver? Silver is here. So it is positive 0.8. Positive 0.8. So I'm gonna come back here and I say silver, you say that silver is the anode, meaning that I put is 0.80. So it's minus, and then I go to lead 2 lead is supposed to be more reactive. You see, this one is supposed to be the anode. I don't know why they put it there. It's negative 1.3, negative 1.3, negative 1.3, negative 1.3, negative 1.013. You see, so now when I subtract, I'm gonna get this minus that. So it's gonna be equal to negative 0.94 volts. Yes, so it's a negative. Therefore, the answer is non-spontaneous. Yes, so you tell us that the answer is non-spontaneous. Define electrolyte. You know the substance that can decompose when electric current is passed through it. Write down the predominant oxidation half that takes place in the cell. So if you are saying that because you are using sodium chloride becomes more concentrated. The chlorine is the one which is more concentrated, therefore it's going to be produced. So it's going to be taken over the hydrogen, taken over the oxygen. So then automatically it's going to be chloride gives me chlorine gas, and then plus 2 electrons. Yes, so I put a 2 there, and then it's balanced. This is aqueous, this is a gas, and then that's it. So I think that's what they wanted. And then I say write down the name and the formula of the product that formed at Q. At Q, basically it is the hydrogen gas, but because they saying name the products, so it's hydrogen gas and the hydroxyl ions. Yes, so that makes to be the answer. Explain the answer and by referring to the relative strength of. So you guys, if you look at sodium, yeah, water and sodium, they are reduced. Yes, but meaning that H2O, when it is reduced, is gonna give you hydrogen ion. Hydrogen ion basically is gonna give you that, and basically it has a less negative reduction potential. You understand? Than sodium. This one has a less reduction potential than sodium. Because sodium is supposed to be sodium ion to this. You see, so automatically this one is going to be preferred than this, so this one is not going to take place. You understand? And then now also therefore water is basically is going to be preferred, therefore, and then you'll be able to get this plus this, because once this one ionizes or is electric current is passed, it's gonna form those ions. So it means that because this one has a lower reduction potential, yes, than sodium, therefore water is gonna be preferred. Yes, is going to be preferred than sodium, and therefore hydrogen gas is going to be produced at that terminal. Ish, guys, I think that is it. Thank you so much for being with me for all this long time. Yes, it has been a wonderful. If you have any challenge, let me know. Yeah, I think, guys, that is it. Thank you so much. Those who tried, yeah, I think I tried to explain. If maybe I used a different formula, some of the formulas you didn't understand them. Yeah, it's the style, but I know that you guys got. Thank you so much for being with us. Don't forget to subscribe, like, and share. Yeah, see you again. Life science. I'll be here with you guys to prepare you in life science full swing, so that I see that you guys will get distinction, because your passing makes me feel good and better. At least I'll say that I've changed someone's life. Yes, thank you so much, guys. See you again in the next class.